Okay, so previously we have gone with the Ackermann's function. So now we shall continue on to the another two more examples. So you have another two more examples on recursion. So first one, so you see here, so another two more examples. So first one is Tower of Hanoi and some discussion about time complexity. So these are the two remaining concepts under recursion. So using recursion, we have gone with so many examples. So examples will include factorial, GCD and LCM, multiplication, Fibonacci series, and so on. So finally, in today's class, we are going with a very important concept, that is Tower of Hanoi. So Tower of Hanoi is the very, very important concept. So, okay, so what is Tower of Hanoi? So what is that problem and how it is going to be solved? That we will see in today's class. So this is the problem. So what's the problem means? So you understand the problem here. So problem will be given with its complexity. It is a worldwide famous problem where complexity grows exponentially. So where complexity, what is the meaning of complexity, that we will see after the problem discussion. So where that complexity grows exponentially. So what is the problem? There are three pegs or towers. So you take it as peg, okay? So take peg or tower, say left, that is source, middle, that is intermediate, and right is destination. So you have to move the disk from left to right. You have to move the disk from left to right. So what is the condition? Number of disks are in left peg in descending order. So descending order means, so smaller one is upper, bit larger is second one, and the largest one is the ground. So that means this is of bigger, so it is reducing in size. So reducing in size, we call it as descending order. So a number of discs are in the left peg are in descending order of their size. So problem is to move all discs from left to right. So from this is the left, this one is the middle, this one is the right. You have to move all the pegs from left to right. Okay, so you have to, what is the problem? Problem is to move all discs from left to right with the help of middle with the following condition. What is the condition here? So conditions are one disk, you should move one disk at a time, and no larger disk on smaller disk. So that means you should place smaller disk on larger disk only. You should not place a larger disk on the smaller disk. So how it is? The last one is larger. So second one is bit smaller than this. So third one is bit smaller than this. So that's why we tell it as no larger disk on smaller disk. There should be no larger disk on the smaller disk. So what you have to do, this is the left peg, middle peg, right peg. You have to move all the positions from left to right using the middle one. So you move all the diskettes from left to right with the following conditions. So condition is you have to transfer one disk at a time, and second condition is no larger disk on smaller disk. So all the smaller disks should be on the larger disk only. So which is the smaller disk? First one is the smaller disk compared to second one. Second one is the smaller disk compared to third one. So this one is first, this one is second, this one is third. Okay. So you have to move all the disk from left peg to right peg using middle peg. Okay. So are you getting right? Getting getting the problem? So are you getting that particular problem? Only one remaining. First you have to understand the problem, then only you can go with a solution. Are you getting my voice is clear? Okay then. So understand the problem. You are having three pegs: left peg, middle peg, and right peg. You have to move all the disk from left peg to right peg using the middle peg. So such that you can transfer one disk at a time and no larger disk on the smaller disk. So that is the problem. So solution is the below one. This is the solution. Left peg, right peg, and the destination right peg is consisting of all the disk. So this one is called as disk. Okay. So how many disk are there? Three disk. Okay. You are moving from left to right using middle. Understanding? So now you come with the algorithm. So what is the algorithm for tower of Hanoi? So it is the algorithm for tower of Hanoi. So function TOH. So TOH means tower of Hanoi. You are having what disk? Where? On left. Where you have to move? On right using middle. Understand carefully. So function name is tower of an eye, and what is the input? Disk is the input. And where is the disk? It is on the left peg. And where it should be moved? It should be moved to right peg using middle peg. So disk is an integer and left, right and middle are the strings. So because left is equal to, you will get it as left, right is equal to right, middle is equal to middle, disk is equal to number. How many disk you are having, that will be the disk number. Okay. So if disk are greater than 0, okay, if disk are greater than 0, what you have to do is take the disk minus 1. So that means if you are having 3 disk, so go with a disk minus 1. This is disk 1, disk 2, disk 3. Total number of disk are 3, and your disk minus 1 means disk minus 1 is moved from left to right using middle. Okay, so left to middle, left to right using middle. So this you have to understand. It's initially is in the left peg. You are moving it into the right peg using middle. That's why you are getting middle in between. Understood? So next you go with a, so next you, once you move the disk, now you are printing that, move the disk from left to right. So this is only the print statement. Now again you call disk minus 1, middle, right, left. So this is the, this I will tell you when I go with the example. So why you are going with the middle. So this one is moving the left to right using middle, and this one is from middle to right. So this one is from left to right using middle, and this one is from middle to right using left. So this is the algorithm for tower of Hanoi. So next you go with the example. So see the example here. So it's been explained clearly. So first scenario is you are having 3 disks. So A is the left disk, B is the middle peg, and C is the right peg. So all disks are on left, that is A. Okay, you have to move all disks from left to right using middle. So how you are going to do? So first you see, take the disk, topmost disk, and move it onto the right. Okay, take the topmost disk and move it onto the right. So come for the second iteration. So now when you move, so how many disks will be there? 2 disks will be there. Now you move that topmost disk to the B. So that's why you have moved here from 1 to 2. You see the, what is the violet disk you are having, that is been in the B. Okay, so now you see, so now you are moving the C, what you have in the second pick. So that is the third iteration. So what the third iteration will do? So what is the smallest peg you are having? You are moving it into the B. So now you move the last largest disk from A peg to C peg. So you have moved from A peg to C peg. So now what you have to do is take the second larger. So first larger has gone to C. So but second larger is in B. So take the green disk, place it on A. So see here, green disk is placed on A. Now you have B. So B is been moved from B is as you move here, B will contain only one, that is violet. So now you can easily move from B to C. So see here, B to C is moved, and finally what is there in A? It is moved here. So this is the problem of Tower of Hanoi. That is it is a step for 3 disk. So it is a step for 3 disk. So A, B, C is there. First you move the smaller disk to C. Second iteration, move the second smaller disk to B. Next, move the largest disk to C. Next, you move the smallest disk to A. So now you move the second smaller disk onto C, and finally third smaller disk onto the C. So this is the scenario on Tower of Hanoi. So getting this illustration, are you getting this illustration what I illustrated there? So how you move the 3 pegs from this A peg to C peg? Have you any doubts in this illustration? Got it? I've given with a diagrammatic. I've given with a diagrammatic how you are going to change. So you should kindly see that, and you should understand this particular Tower of Hanoi. Are you getting right? Okay then. So this is the illustration what we have taken for the Tower of Hanoi for the 3 disk. So now you go, if you have got understood this particular thing, now you go with the program. So this is the program we have taken. Okay. So first this is the function. So this part is the function part. You start from the main. So in main you are getting int d. How many disk? Okay. So here it is percent %d ampersand d we have taken. So d is equal to, we can go with 3. You can go with 3 or you can go with 4 also. So now I call a function d comma left, right and middle. So this is the what you tell. This is called as a calling function. So calling function, the D is nothing but number of disks, and you are moving from left to right using middle. So first comes source, dest comes destination, source, dest, and this one is called as a temp. Okay, source comma, destination comma, temp. So temp is nothing but middle. Okay, so that is the calling function. So calling function will be always inside the main. Now we are going with a called function. So what is a called function? It will be outside the main, and we give it as int d comma. Now you see there you have taken it as left, right. There you have taken it as left, right and middle. Here I will take it as different name, that is char L. So left will be taken as char L, and right will be taken as R, and middle will be taken as M. If D is greater than 0, so what you have to do? So understand here, what you are doing here, kindly you have to understand. So come for this particular diagram. So first we are moving from left to, so first see the first disk. You are moving from left to right. Okay. So after that, after left to right, what is the next one you are doing? You are moving from left to middle. First scenario, first condition, moving from left to right, and second scenario, you are moving from left to middle, and third scenario, you are moving from middle to right. Understand carefully. So first from left to right, first scenario from left to right, second scenario from left to middle, and third scenario you are moving from middle to right. So that's why you see here, first we have gone with left, middle, right. So understand here, you are moving from left to right using middle. So give the scenario as left, middle, and right. Okay, so once you move from left to right using middle, you are going to print. Okay, so print, you can take it as percent 7D, or you can take it as percent D also. Percent D. Okay, move disk percent D from percentage to percentage. So what is this percentage? So percentage will stands for left, and this percentage will stands for right. So move disk 1. Move disk 1 from left to right or left to middle. So this one is called as a disk number. So disk number we take it as D, and next this plus k is for this number. Okay, how many iterations we have gone, that is going for k. Okay, percent 7 LD means it is going with k, so keeps on incrementing. Okay, so plus k, it is for number 1 to 15. So 1 to 15 keep on incrementing for each iteration. Next D means move disk number 1, this percent is for D, and this percent 2% are for left and right. Okay, so once you move from left to right, another situation is move from middle to right using left. So using left, right, middle, next you go with a middle, right, left. Okay, just you transfer this L to here. Okay, so left, middle, right, and next one is middle, right, and left. So this is the problem on Tower of Hanoi. Understood? So have you understood this particular program? Have you understood this program? Okay. So you use this particular attendance link to answer the attendance. So answer your attendance using this particular link. Okay, next you come for the how much time taken. Okay, so how much time taken, now you analyze if the number of disks or more, so how much moves, how many days, and how many years have been taken. So according to the Tower of Hanoi, so if the number of disks are 20, so how many moves you have to do. So for number of disks is 3 or 4. So go for this particular program. So if the number of disks are 4, how many moves you have done? You have gone with 15 moves. Okay. So similarly, if the number of disks is 20, how many moves you have to go? You have to go for this much moves in this much time, days, and with this much years. So this is the analysis on how to move the how much moves are taken chosen to and how many days have been taken for this solving the tower of Hanoi problem. Okay, so next, if you have taken the disk as 30, so how many moves? This is the moves and this much days. So this is the analysis done on how many moves are taken to move the data 20 days, 30 days, 40, 50, and 64 disk. Okay, so next you come for the next problem, that is complexity. So what is the complexity means? So how your system is been working. Okay, so how your system is working, so that you have gone with a two, one is space, the other one is time. So go for any program, number of lines or number of space, how much space taken to type the program. So that one we take it as space complexity. So what do you mean by space complexity? The number of lines taken to execute the program. So how many lines are there and how much space is being taken. That when we call it as space complexity. And once you type the program, so how much time taken to execute the program. So how much time taken to execute the program, that we call it as time complexity. Space occupied by the program is called space complexity, and time taken by the program to execute without any errors is called as a time complexity. So understand these two words, it's very, very important. So this one you are going to see in details in the fourth semester subject, that is design and analysis of algorithms. Okay, so there are two complexity, one is space, the other one is time. So space complexity will be always the space taken to type the program. And what is time complexity? It is the time taken, it is the time taken to it is a time taken to execute the program, that when we call it as time complexity. So time complexity is nothing but number of operations, or you can go with number of iterations. So these are the some of the space and time complexity details. So how you are going to represent the time complexity, it is in terms of big O notation. So for example, I am giving here for sorting like selection and bubble sort. So you are going with a big O of n square, and for searching you are going with a log n to base 2, and for tower of an eye you are going with 2 power n. So these are the big O notations. Okay, so these are the big O notations used for time complexity. So time complexity will be always in terms of, so time complexity will be always in terms of milliseconds, and space complexity will be always in terms of GB. You can go with MB or GB. So time will be always in terms of milliseconds, and space will be always in terms of MB or megabytes or gigabytes, or even you can go with terabytes also. Okay, so this will be the time complexity, how you are going to measure. So unit for measuring the time and space complexity is, time will be given as ms and space will be given as MB or GB or TB. Understood? So understood this particular concept? So now can you answer, can you tell what is time complexity? Answer, what is time complexity? Yes, tell me. Time taken to execute the program. Yes, time taken to execute the program without any errors. Okay, good. So time taken to run the program. Yes. So what is the space complexity? What is space complexity? Space taken for what purpose? Space taken to type the program. Okay. Okay, good. It is a space, memory space required to solve taken to store the memory, no space taken to type the program. So that one we call it as space complexity, and it will be always in terms of MB or GB or TB. Whereas time means it will be in terms of milliseconds. That is MS. Understood? So now you come for the next questions. So can you answer? So first, total number of movements for n disk to solve the tower of Hanoi. So if there are 3 disks, if there are 4 disks, it is going with 15. So if there are n disks, so I've given if it is 4 disks. So 4 disks will go with 15 moves. So n disk is equal to how many moves? Answer me. Total number 4 moves is equal to 4 disk is equal to 15 moves. So n disk is equal to how many moves? Yes, answer. I've given you one hint. So if 4 moves is been for 4 disk, it's been taken 15 moves. So for n disk, so yeah, what is the formula you will be getting? Can you tell? Yes, anybody? Just you get something equated with 4 and 15. 2 power n minus 1. Okay. So it's 2 power n minus 1. Okay. Priya B, you are good. So it's 2 power n minus 1. So as you go with a 4, so it is 2 to the power 4. 2 power 4. So 2 power 4 will go with 16. So 16 minus 1 will go with a value 15. So similarly, if you are going with a n disk, so it will be taken 2 power n. So 2 power n minus 1. So this is the answer. Okay. So total number of movements for n disk is given by 2 power n minus 1. Okay. Next, come for the next one. Maximum number of comparisons to sort using bubble or selection sort. Maximum number of comparisons. How many comparisons you require? Using bubble sort or you go with a selection sort? So maximum number of comparisons, how much? Anybody, can you tell? Just you go with this complexity. See here, to tower of Hanoi, it is 2 power n. For searching and sorting, maximum number of comparisons, it is given as n square. So maximum number of comparisons that you are going with, it is, so it is n square. So how many comparisons you go? Number of elements with 2. So that will be the maximum number of comparisons you can go with. Understood? So how you are going to do, so that you can take it as n square. So maximum number of comparisons to sort using bubble or selection sort will be given as n square. Understood? Similarly, maximum number of comparisons for binary search of 1024 sorted elements. So binary searching for 1024 sorted elements. So what can be the answer? So how many binary search, what is the answer? It is log n to base 2. So now for this one, you have to take it as log of 1024 to the base 2. So log of 1024 to the base 2. So this will be this much number of comparisons is required. Got it? Understood all concepts? So this is up to, that is a second module of part is finished. In second module, first topic is stack. Next one is recursion. So recursion is going to end it here. So in remaining, this will be the end of stack and recursion. End of stack and recursion. So next you will go with a next concept, that is queues in tomorrow's class.